So the top part of this is just kind of a review, a little bit of a review over really 12.1. Okay, so make sure that you know where those two buttons are to put in log and natural log. It says when you see y equals log x, it is assumed that you're using a base 10, so that right there is the exact same as y equals log base 10 of x. It is frozen. There we go. It says this is what is known as common log. The calculator key marked log refers to the common log and uses a base 10. Now, what is the other way that I had mentioned how you would put log in the calculator? This is the way where you can change the base. You'll probably use this way more than hitting the log button. Alpha window 5. Write this somewhere on your notes. Spencer, that involves picking your pencil up. That's going to allow you to change the base. Now, in today's notes, we're talking about transformations. Pretty much anytime you're going to deal with transformations, you're just going to have that common log with the base of 10. But whenever you're dealing with converting from exponential to log, or vice versa, or if you have an application problem, you're going to have a lot of different bases. So make sure that you know how to put that in correctly. After that, it says rewrite y equals log of x using the exponential notation. Okay, so Jackson, what is understood to be right there? 10. So if I'm going to write that, then also going to, also known as writing its inverse, because I'm going from log to exponential. So the first thing I would do is switch x and y. And if I'm rewriting that, that's that fish hook, what we talked about in 12.1. So whenever I fish hook this, where do I start? At the base. I'm going to start at the base. So I've got 10. Then I go to where? To the power of x equals what? Y. Okay. Or y equals 10 to the power of x. However you want to write that. Okay, looking at 10, it says evaluate the following. Now you could put these in your calculator. First couple though, we're going to fish hook, because I want you to make sure that you're aware of something if you do have to fish hook it. So I'm going to set this equal to x because I'm just figuring out what this equals. So if I fish hook this, I'm going to start on the base, which is right there, which is 10. And I'm going to have 10 to the power of equals, okay, and this is why we're doing this right here. If what is called, this is not the base right here. Okay, this is what is called the analog right here, 10 cubed. And so if that has an exponent, you have to include that. Okay, the understood 10 is not written down there, and that's the base. That's where we start. And so I end up with 10 to the power of x equals 10 cubed. And so x equals what? 3. Okay. So whenever you fish hook, because a lot of times you'll have to do that, and it's not something that you can just put in your calculator. You need to make sure to include that exponent whenever you fish hook that. So go ahead and do those next 3, see what you get. You might be able to do those even without the calculator pretty easily. So do me a favor, if you are pre-cal bound, I want you to try to do those without the calculator. If you're headed to AQR and you're really not sure where to start on that, you can go ahead and use the calculator on those. Okay, so on B, if you fish hooked it, you got 10 to the power of x equals 10 to the power of negative 3. So x equals negative 3. Now on the next one, it's not as obvious, but still not very difficult, I don't think. You would end up with 10 to the power of x equals 100, so what is x? 2. 10 squared equals 100. And then on D, 10 to the power of x equals 1 over 100. So x would equal what? Because that negative is what makes it the fraction. Going down here again, this is what is called the common log. And the next one is what is called the natural log. Okay, so these are the same. Make sure that you wouldn't write it as ln with a base of e. Okay, it would be log base e, which is the same as that natural log. Okay, you could really you could put it in your calculator either way. Alpha window 5 and put that little e down there, or you can just set that natural log. Let's go down here. Let's see how many of you remember some of these from 12.1. So if I have log base b of b, what is that going to equal? And remember kind of the mindset. It's kind of a different mindset whenever you're doing logs. B to the power of what equals b? 1. Okay, so if I go to just log 10, what's that going to equal? 10 to the power of what equals 10? 1. Remember, this right here is the same as natural log is the same as log e. So log base e of e equals, Alexis, 1. Fabulous. Okay, so just if that base and the inner log are the same thing, then it's pretty simple. Okay. So going down to these 4, this is just trying to just so you know where the natural log button is. Okay, I want you to solve those round to 2 decimal places. So these you will put this in your calculator. Anytime you're doing natural log in E, probably about 110% of the time you're going to have a decimal. Okay, so do that math, Ayla. 110% of the time. So on A, you should have gotten, Kate, what do we get on that? 2 decimal places? 0.9, does that round up, though?
Yeah.
Okay. And Jackson, B? Okay. All right. Ayla, what'd you get on C?
AJ and I are struggling on that one.
Okay. Did anybody get C? Okay. So, obviously, and you probably noticed it, the location of where X is, that's what makes these a little more difficult, but it's not real hard. You just got to know that whenever X is over here and X is part of the log, to get it out of the log, you need to fish hook that. Okay, so if that is the same as this right here, and I fish hook this, where am I going to start? The E. So I've got E to the power of equals, and so now you just have to put in that. How do I put E into the calculator? Second division, or second divide. So do that, figure out what that is, and then go ahead and do D as well. Okay. That second one should round up. If I did it correctly.
Oh, yeah.
And Lily, what'd you get on D?
221.41.
They may not get those or have a question on that. Alright, so let's go to the back. So I'm going to list out the transformations. They're the same as they always are. Just, we just got to figure out kind of what the graph looks like a little bit. Where the C is, where the D is. Even though it has B up there, we're not really going to talk about B that much. That B up there stands for base. That is not the horizontal stretch and compress. Okay? But obviously we will talk about the A. So let's make sure we get all three of those situations for the A. So AJ, if A is greater than 1, what does that do?
Don't tell me. Vertical stretch.
Vertical stretch. Kate, if A is less than 1?
Compress.
Vertical compress. And Michael, if A is negative?
Fucks over the x-axis.
Okay. Paulina, what two directions does the C value move it? With or opposite the sign? Opposite the sign. Noah, what two directions does the D value move it?
Up and down.
Opposite or with the sign?
With the side.
With the sign. Next to the C value, I also want you to put VA. Okay, and we'll kind of expand on that here in just a minute. So I'll give you... Okay, looking at the first graph. We'll use a couple different values. I'm going to show you how to find a couple points by hand. And if those of you who are pre-cal bound, you'll need to know this for sure. So, but go ahead and put the equation into y equals and go to the table. Okay, so, and again, whenever we're doing transformations, you're not going to have to worry about the base. So whenever you're putting these in, you can just hit the log button.
But you won't have a base if it's...
Well, you won't have a base other than 10. It'll just be the common log. So whenever you put it in, you don't necessarily have to do the alpha window 5. And we'll look at those tables here in a minute, but I want to talk about a few different things as far as finding the vertical asymptote, easy ways to do that, and then talking about your domain and range. So a couple different ways. How the 2 points that you'll need to find is whenever you have this log, so it's log base 10 of x, you want to figure out what is going to make the log equal 1 and what is going to make the log equal 0. Okay? And so, think about this. 10 to the power of what? Sorry, 10 to the power of 1 equals what? 10. So one of the x values I'm going to have right there is 10. Okay, 10 to the power of 0 is what? 1. And kind of follow me here because this is, finding these 2 points. I don't think it's not that difficult once you kind of get a handle on what we're doing here. So whenever I plug 10 in for x right here, okay, this whole thing is log base 10 of 10, which we already said equals what? We wrote this down on the first page. It equals 1, right? Log base 10 of 10 is 1. So I've got 2 times 1 plus 4. Okay, negative 2 times 1 is negative 2. Negative 2 plus 4 is 2. Now whenever I plug 1 in there, log base 10 of 1 equals what? 0. That's what we were doing over here. We just had to figure out what this x was. Log base 10 of 1 is going to give me 0. So now I'm going to have negative 2 times 0 plus 4. Negative 2 times 0 is 0. 0 plus 4 is 4. And so that's going to give you 2 of the points that are on there. So I've got 10, 2, and I also have 1, 4.
Do you have to do it that way? If you put it in your calculator?
You do not have, say that again.
Like if I put it in y equals and I look at the table and it already gave me those 2 points, do I have to solve for it that way? Like
No.
the table always.
No, you can do it in y equals.
Okay.
Okay? But, well, saying, those of you who are pre-cal bound next year, you're going to have to do that by hand. So you can't just, I don't want you to just become so reliant on the calculator. You're going to know how else to do it. So after that, you're going to have to kind of know where that vertical asymptote is, which I told you was the C value, correct? That's why we wrote the VA after that. But make sure that you know that C value, it's opposite the sign, but on this problem right here, AJ, what is the C value?
C. Is it not?
What is
I said 0.
0. Sorry, I didn't hear you say that. So on that one, this one is 0, which is going to make my vertical asymptote x equals 0. So there's my vertical asymptote. It's just right on the y-axis. And then you can follow that vertical asymptote and start to curve it. Not quite that much. Okay. And you can get those 2 points. I would highly recommend, though, that you go to the table and you find a couple other points, like, usually some that's really close to a whole number. Like this one right here, you got 3 and 3.04. So that's close enough to 3. Okay, just to get a couple other reference points on there. An easy way that you can find the vertical asymptote from the table. So kind of look up there at the calculator. The vertical asymptote, it is going to be the first x value that has error on it. Alright, so now know that this one is reflected because of the negative at the beginning. Usually the errors will be at the bottom, and so it'll be that first one you come to as opposed to the top. If it reflects, it'll be like that. So we'll look at the other situation on the next one. On this one, what is my range going to be on this? We talked about whenever we were talking about exponential, what was our domain? All real numbers. Well, if log is the inverse of that, so all the x's that gave me all real numbers on exponential are now my y's for logarithms. So what is my range? All real numbers. What would my domain for this be? 0 to infinity. That is going to be your domain. We don't, on the next one we have the reflector of the y-axis. We're actually going to take it off because we don't really have to deal with that. Okay? So it is always going to be your vertical asymptote to infinity. Yes?
I don't know if you told us if you did after that. Why would you pick a bracket of the 0?
Because it will never actually equal that x value. It's going to, because an asymptote, it gets closer and closer and closer to it, but it's never equal to it. And a bracket means that it's equal to it. Yeah. Okay, questions on that? Fabulous. This, move it over. Pop that back up. No, that's not going to work. Does everybody have all that written down? Awesome. Okay, so let's look at this next one again. Go ahead and take this negative off. We're just going to deal with that. Okay, so we already, and we've discussed this a few times. Okay, one of the things that we're looking for is log base 10 of 10 so that it will equal 1, right? So on this situation, what x value is going to give me log base 10 of 10? If I want this to equal 10, what x value is going to make that happen? 8. 8 plus 2 is 10. Okay. And then if I want this to equal 1, what x value would I need to plug in there? Negative 1. Okay, so let's do this real quick. So whenever I plug 8 in there, that turns that whole thing into log base 10 of 10, which we already said is 1. And then I've got this minus 1 at the end, so that equals 0. Whenever I plug in whenever I plug in negative 1, that gives me log base 10 of 1, which that makes all of that in the purple box 0, and 0 minus 1 is negative 1. Okay, so let's plug all of that, put all of that into your calculator, and make sure that those 2 points are in your calculator. Okay, so Noah, what's my range going to be? All real numbers. Always and forever, right? Okay. Lexus, on this problem, what is my C value in that equation? Yes, ma'am. No. This equation. Yeah. What is the C value? It's what? 2. So if in the equation it's positive 2, what is my vertical asymptote? X equals negative 2. And so, Kate, that means that my domain is what? Negative 2 to infinity. Okay. So let's go to the graph and actually graph this. So I've got my vertical asymptote at 8 equals negative 2. I've got, where are my points there? 8, 0. negative 1, 1. Now, if you graph this and you go to the graph, it probably looks something like this. Oh,
Wait, -1? Oh, -1.
yep, negative 1, 1. Okay, and it kind of stops here and it doesn't go down. You need to know this whenever you're graphing these, because if it actually stops there, then my range is not negative to positive infinity. But we know that the range is always that. That is because the calculator, for whatever reason, calculators cannot graph a straight vertical line. These graphing calculators. You need to know that it does follow that vertical asymptote all the way down. Okay. I do not know. You should send a nasty email to Texas Instruments and complain.
I ordered a new calculator.
All right, so let's go to these real quick. These should go pretty quick. This is just, here's an equation, what's the transformation? And the next two are what, here's transformations, what's the equation look like? So, Audrey, what are one of those transformations on there?
Left 5.
Up 5. And let's somebody tell me why this is not left 5. It's not in parentheses. That is the biggest mistake in this unit, is people see that when there's no parentheses and they look at it as a C value. C values only exist if there are parentheses. Okay, what is the other transformation? Awesome. Going to B, Cade, what's one of the transformations?
Right two.
Lily, what's the other one? Sierra on C.
Vertically compress spiral.
Maddie.
Left 2.
Erica.
Up 2.
Yes.
Why don't you, whenever it vertically compresses, why don't we ever do the reciprocal?
That's the horizontal compression stretch. You won't have to on this stuff. Okay. So, going down to this next one. So we're applying these transformations to the common log. Okay. So, Molly, what would that equation be if you applied those three transformations to that equation?
No, around the x -3.
The x and the negative 3. Okay. Got it. There we go. Pardon?
I want to redo myself.
Okay. Alexis, what is B?
Okay. -1/2. 1/3. I'm so tired.
It's looking rough already. Go ahead, though.
X plus 2 with parentheses around it. -3. 8 plus. That's still good.
Oh, oh, oh.
Hey, why are you growing your mustache?
So, looking at, and these are pretty quick. Looking at these these graphs. Again, the range is always going to be what? Okay, so go ahead and put those on there. Now, let's make sure that we know, given a graph, how do I identify the vertical asymptote? And it's just where the graph starts to flatten out vertically. So, on the first one, Joey, what would the vertical asymptote be?
I would say 0.
How is it flattening out? Right there.
Oh, vertex, okay. -2.
Okay. What do I need to put in front of that?
X equals. Y.
Yes, x equals.
Y.
Miss Wallace, what is the domain?
-2 to infinity.
Okay, going to the second graph. Ayla, what is the vertical asymptote?
X equals 3. I'm sorry, that's.
She was so confident.
That's not.
And so, Elijah, what would the domain be?
Maybe 5 to infinity.
Remember that if you were to graph this, you would need to extend that down.